6-6, college algebra, last lesson of the semester. What we will do is find where the polynomial function or a rational function, depending on what they give us, is either greater than or less than 0. We want to know when it's like positive or negative, stuff like that. So first, let's realize that this is just a plain old polynomial function, and he is in an awesome shape for us already. Isn't he in factored form? Right? We know the roots of this already. The roots are where? If my pen would write. Roots are at -3 and at 1. Is there any multiplicity in this situation? Which one's got multiplicity? 1. So what we'll do is we want to know where the roots are at. So we plot them on this cool little sketch that we'll make. One of them is at -3. The other one's at 1. But even though we probably have a little bit of knowledge of this guy, we could probably sketch this one without a graphing calculator. We might as well use our graphing calculator to see what this guy looks like. So we got to punch that guy in. So what our idea is, get everything over here and on the left side and have 0 on the right side. So we just punch in the left side, just how it is. I'll zoom 6 in, see what he looks like. I should know where my roots are at already. If I trace -3, it should be a root, which it was. And if you traced 1, it's got a root. You'll see it didn't cross the x-axis either because of the multiplicity. Let's just make a nice little sketch of him. Doodly doodly doo. Doo 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 doo. Like so. Cool with that? They want to know where this graph is greater than 0. Notice it does not have an equal to bar, so where it's greater than 0 is when it is above the x-axis. Would you all agree that right here, that's above the x-axis, correct? And also right here. But I skipped over this dude. Why did I skip over that particular point? That's where it's equal to 0 at, right? So all we have to do is write an interval notation where this thing was positive. We graphed him, and where he's positive is where he's above the x-axis at. So reading from left to right, where do we start at? -3. And does that count? No, because they didn't use an equal to bar, so -3 is not included. Then it goes all the way to 1, right? Also not included. Then union it, start over again at 1, and go to infinity. Isn't that the values of x that make him greater than 0 in this situation? Nice, neat little sketch. Remember, it couldn't actually be 1, because if x was 1, it would equal 0, and that's not part of the deal. Let's do the next one. Polynomial. Also, it's not rational. There's no fractions or anything going on in that situation, but he's not 0 over here, so wouldn't we subtract this bad boy over? So you get this, right? Let's graph him and see if the roots come out nice. If they don't come out nice, then we got to do a little synthetic division. So x to the 4th minus x. I'll zoom 6 in. Ooh. Ooh. How many roots should this thing have? 4 possible, right? Maybe some of them are imaginary, maybe not. Maybe there's some multiplicity, maybe not. But what we need to do, I can't tell much from right there. Let's zoom in a little bit. So what do you want to go by for our x's and y's to really zoom in on this zone right here? Let's go by 2's all around would be fine. 4 would have been fine also, but let's go by 2's all around. X min, -2 to +2. Y min, -2 to +2. I'm just trying to zoom in and see that better. So if I hit graph then, I will see 2 roots. That's better, right? Better for me. Let's guess where they're at. Probably at 0. Trace 0. That was a root. Looks like 1 also. Trace 1. That's a root. So at 1 and 0. Make a silly sketch of him. Silly sketch. Do a little squiggling. We want to squiggle where that thing's greater than 0. So is that above the x-axis or below? So meow, 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 meow. 2 different intervals. Do these points right here actually count in our intervals? No, they did not have an equal to bar. So we read from left to right. This squiggle went from -infinity to 0, not included. Union, start it over again from 1 to positive infinity. Cool? Nice. Probably means that you've got multiplicity of 3 roots right there in that situation. Next guy, this is where we're going to run into some, problems. We've got rational situations. So before we do a cool little sketch, we will find all our asymptotes first before we make a sketch. Let's do vertical asymptotes. Is this dude in factored form? First of all, you got 0 on the right side. Is that factored as completely as possible? That's a difference of squares. So isn't he really, let me get rid of this. You got x minus 1 over, what's this factor to? X plus 2 times x minus 2. And it's still greater than or equal to 0. You all cool with that? Any holes in this graph? No holes. Vertical asymptotes. That's where the denominator equals 0. So we got a vertical asymptote at x equals 2 and x equals negative 2. Horizontal asymptotes. Let's see. The numerator's degree is smaller than the denominator's degree. So what do we got? So horizontal asymptote right here, because the numerator is smaller at y equals 0, meaning there is no oblique asymptote, so I don't need to write that down. Cool. Put them in. X equals negative 2. X equals 2. And y equals 0. Now you'll learn something about asymptotes that you probably may have never seen. It's hard to explain asymptotes to students because they don't understand them. Even us as math teachers, it's hard to kind of realize what they are, but it's not a line that things approach and never touch. That's a false statement. Things can actually touch horizontal asymptotes. So let's graph this. All that the asymptote is, it tells you more about the end behavior of what's happening as things get closer and closer to positive infinity or closer and closer to negative infinity. So graph that for me. These parentheses. You got x minus 1. Where's my parentheses? Divided by x squared minus 4. Got to change our window back to zoom 6, right? Because then we move it around. And you get this cool little nugget of thing going on. First of all, I want to know I've got asymptotes here and here, and I've got an asymptote there. This thing, though, crosses that horizontal asymptote. This dude will not cross the horizontal asymptote. This dude will not, because as you get closer and closer to infinity, this thing will get closer and closer to y equals 0, y equals 0. But I need to know where the x-intercept of this guy is also. So, looks like 0. Let me trace 0. Is that the x-intercept and the y-intercept? That's the y-intercept. So, let's try again. Let's zoom in if you want to, or try another integer near there. Trace 1 if you want to, see if it works. That's where he crossed the old x-axis at. So, if this is 2, let's put 1 right here. And notice that that dude is actually touching that asymptote. You can touch horizontal asymptotes. So then this thing slithers up this way and slithers down this way. You will never touch a vertical asymptote because that gives you a denominator of 0, and that's undefined information. But as this thing gets closer and closer to infinity, then this is going to happen this way, and this is going to happen as it goes to negative infinity. So you got those 3 parts of our deal. Now we got to do a little squiggling or highlighting, whatever you want to do, where that thing is greater than or equal to 0 at. That's where it's above the x-axis, or actually on the x-axis. This branch, any squiggling on him? He is completely below the x-axis. Here, right? Not here, though, because that went below the x-axis. What about this branch? Anything on him? All of it. All of it is above the x-axis. So if you were squiggling or if you were highlighting, whatever, now we take those two and write them as intervals. How far to the left will this thing go? To -2, and will it actually touch -2? Nope, there's a vertical asymptote there. You will never touch a vertical asymptote. And then it goes all the way to, this place was 1, right? So 1, 0. And does it count? Does 1 count? Yes, due to the equal to bar. Start over, new deal. Goes from 2, does 2 count? Nope. To where? Infinity. Woo! Fun stuff. Next one. What's the problem with this guy? Not equal to, I shouldn't say equal to, but this is not a 0 right here. What do we got to do first? So you got 4x plus 5 over x plus 2 minus 3 greater than or equal to 0. Sweet. Let's find some asymptotes since this is a rational situation. Vertical asymptote. Still got a denominator here, right? Where would that puppy be at? X equals -2. Horizontal asymptotes. Read him first. Horizontal asymptotes, the degree of the numerator and the degree of the denominator are the same, right? So that's this situation. So it should be y equals leading coefficients over each other. Wouldn't that give you y equals, let's do this, horizontal asymptote, y equals, leading coefficient is 4, leading coefficient is 1, so 4 over 1, right? You would get y equals 4. But something happened to it. Didn't we do this? We subtracted 3. And you know your purple note card stuff, isn't that a shift down 3 units? So if you were at y equals 4 and you go down 3 units, where is your horizontal asymptote really at? Y equals 1. There was a horizontal asymptote at y equals 4, but because we had that minus 3 in your purple note card, graph translation theorem, you had to take 4 minus 3, and now it is at y equals 1. And there will be no oblique asymptotes. Sketch this guy. Vertical asymptote, x equals -2. Don't forget to actually put that in your sketch. Don't just put a little vertical deal. Put x equals -2 either above it or below him. Horizontal asymptote at y equals 1. Then punch him in. Interesting how you got to punch that in, right? Because you got to throw that -3 in there. So to punch that in, clear all this stuff out, you need like double parentheses to start out with. You're going to put this whole thing like in parentheses, but this has to be in parentheses, and so does this. So you will have parenthesis, parenthesis, 4x plus 5. That's your numerator, all closed up right there. And you divide it by x plus 2 has to be in parentheses. And now you close that up completely. So you had the double ending and -3. Zoom 6. Cool. We need to know these x-intercepts or y-intercepts and all that cool stuff. That's the important part about it. We really care about the x-intercept. If you was to guess, where would you guess that's at? Let's try it. Trace 1. Haha. Nice. 1, 0. Anything else we don't care about, right? We've got that thing. It's going to just do this, newt. It's going to go through this and approach this horizontal asymptote and come down here and approach this vertical asymptote. All we care about in these problems is x-intercepts and, of course, asymptotes, right? But the x-intercepts because we want to know where this thing is greater than or equal to 0 at. So we've got to highlight or squiggle everything that's above the x-axis. All of that, right? And that portion. Correct? So, as an interval, where did this thing start from? From left to right, all the way to -infinity. And then it's moving to the right, moving to the right. How far right will it actually approach? To -2, not included because that's a vertical asymptote. Unite it with, starts over again at 1. Does 1 count? It's all about Mr. Equal to bar if you have him or not in that situation. 1 does count to infinity. Sweet. They get a little hairier. How we feel so far? Nice. First, this one's really hairy. Hope you wake up for this one. Not equal to 0, even though it's not an equal to. Move everything over. Noise. Will this one have asymptotes before I get started? Like, what do you think before we get started? Is there anything in here that's just not cool? Aren't you dividing by x somewhere? That's not cool. This is a rational situation, even though it doesn't look like it, because they separated it all out. So what I want to do is I want to get a common denominator between all of these. That will help me write it as one little cool fraction, like what these guys are. Aren't these just like one fraction right here? I want to write him as one cool little fraction. This denominator is x. So if I put all of these over 1, which they really are, what denominator would I want to get them all to be as? Common denominator. I want them all to have an x. So what would I have to do to this guy to get him to have a denominator of x? Times x over x, right? And same thing here, times x over x. I want them to all have a common denominator of x. Don't write this down, but just watch me. Wouldn't this be x squared over x plus 12 over x minus 7x over x less than 0? And you take him times x to keep it balanced, and 0 times x is still 0. But y'all cool with that's what this is. This became x squared over x. This already was over x, and this is minus 7x over x. Cool? The reason why we did that is so we could put it all over x now. And this, I've got x squared plus 12 minus 7x. I don't like the order of that. I like x squareds to come first. Which one do you really want to come second? The 12 or the minus 7x? Minus 7x plus 12, and that's going to be less than 0. So if you wanted to write that step in the middle, you could, but you needed to change them all to get a common denominator of x, so you could write it as a nice, neat-looking rational function to where you've got this numerator over this denominator, and I also put him in standard form so I could factor him much easier. So let's start with vertical asymptotes. That's where the denominator equals 0. I got a vertical asymptote at x equals 0. Horizontal asymptote, the degree of the numerator is larger than the degree of the denominator. Degree is larger than the degree of the denominator. There are none. Will I have any oblique asymptotes? Oblique is if the degree of the numerator is 1 more than the degree of the denominator. Will I have oblique asymptotes? Yes. So I need to find it by synthetic division. The weird thing is, what do you synthetically divide by? It's like you have to synthetically divide by what makes that 0. What makes that 0, baby? So you synthetically divide by 0. You are not dividing by 0. You are synthetically dividing by 0, which is totally a legal thing to do. You have a 1, then a minus 7, then a 12. 1 comes down. You get a 0 out of that situation, and then you get a minus 7, and then you get a negative 0, and then nobody cares. Where's my oblique asymptote at? Y equals x minus 7. Nice? So let's make some sketches of those two things. Vertical asymptote, right here. Oblique asymptote, you can rough guess him. That's in slope-intercept form, correct? What's the y-intercept? -7. It's got a slope of 1, so just rough guess. That's y equals x minus 7 for an oblique asymptote. Cool. We really care about x-intercepts also. You could use your calculator to find them if you want to. You could see if that guy factors, which he does very easily. But since we need the calculator, why don't we just use the calculator? Type. I would not type this in. That would be a mess. Type this in instead. So that is, in parentheses, x squared minus 7x plus 12 divided by x. Uh-oh. Do we see it all? That's the standard window. Hopefully you realize if there's a little branch right here and you've got vertical asymptotes, there better be a little branch down here also. So do we see them all? No. Change your window to be, what's got to change? Y min. Let's go down to -20. Let's see. Because I need to get lower. There I see that little part. So that really helps you out to know that you do have a branch down here. I'll move this out of my way for a second. Oh, please don't let me hit stop. I got a branch down here, and don't I have a branch here? But I need to know where my y-intercepts are. Let's take a guess. It's two numbers that multiply together to be 12 and add together to be -7. Aren't those -3 and -4? But then the roots would be 3 and 4. So if you trace 3, there's one. And then 4 is the other one. So you make a cool little branch to go through those two places. Your calculator would have found those roots for you if you traced and guessed. You just factored that guy. He's x minus 3 times x minus 4. The roots are 3 and 4. So back to the inequality. We want to know where he's less than 0 at. Less than 0 below the x-axis. That whole branch right there. And this nugget right here. Cool. Let's write that in interval notation. Starting from left to right, this branch goes on forever and ever and ever, so doesn't he go from -infinity all the way up to this vertical asymptote, which is located where? 0. Not included. Union. This little nugget starts at 3 and ends at 4, but are they included or not included? Not included, so from 3 to 4. Cool. Your job. Whew, I'll do this one with you. So that was our answer, where that thing was less than 0. This dude got a couple things to do. First, since we got all this junk over here, we need to move it over there. But first, wouldn't you want to factor this, or excuse me, expand that guy right there? So FOIL him out. Then you get some like terms, so I'm going to combine those right away. Bring that other side along with it. The left side is x squared minus x minus 6. The right side was already expanded out for us. We want to get him having a 0 over here, so wouldn't you subtract this x squared over? And what would happen to those? Gone. You would subtract 3x over. Negative x minus 3x is negative 4x. And then you'd subtract 5 over, and you get minus 11. Yeah. This is not rational at all. It is a polynomial, meaning no asymptotes are going to happen. The only time you get asymptotes is when it's a rational polynomial over polynomial. I hope you know where it crosses the y-axis at. Where does this line right here that you just graphed cross the y-axis at? Negative 11. But what you really care about is where it crosses the x-axis at. So the way you could do that is also graph y equals 0 and find the intersection of those two places. That could calculate, intersect, first curve, second curve. It's over here somewhere. Negative 2.75 is where those intersected. Take your straight edge. I guess it's a sketch, my bad. It's a sketch, so sketch those together. That thing crossed the x-axis at negative 2.75. I found the intersection of y equals 0 at that line. And I want to know where he's less than 0, so where would you squiggle, above or below? Below. Interval notation, starting at negative 2.75 is as far left. Does he count or does he not count? Not count to negative infinity is where that thing would go to. To positive infinity, thank you, my bad. To the right is where we're moving. Even though that thing is going down, it is moving further and further to the right, so to positive infinity. My bad. Last one. Oh, I guess not. 7. You do this one on your own. Pause the video. Give it a shot. It's rational, so you find all the asymptotes. Even though this dude's factored, you need to expand him out so you can find your asymptotes. Vertical asymptote at x equals 1. There are no horizontal asymptotes because this numerator is really degree 2, and that's bigger than the denominator. So since he's 1 smaller down here, you synthetically divide by 1, and you had needed him expanded so you can get those coefficients. Y equals x, so I'm going to sketch. There's y equals x as my oblique asymptote. Got a vertical asymptote at x equals 1. When I type this in my calculator, it is much, much easier to type the expanded version of your numerator in than those parentheses, because you'd have to do double sets of parentheses. You'd have to put parentheses around it here and then here before you divide by x minus 1. So type the numerator in as an expanded person and divide it by x minus 1. Zoom 6, see what he looks like. And see, that little graph on your calculator is good enough to see, but you don't really see what's really going on because it's all barely curved a little bit. It's hard to see that there's vertical asymptotes going on there. And even an oblique asymptote, if your eye's trained well, you can see that there's an oblique asymptote there. With the sketch, you got your branch here. Oh wait, I need my x-intercepts. Anybody know where the x-intercepts would be at? Negative 2 and 3, because that was already factored. Right? X-intercepts are where the numerator equals 0. And then when you graphed it, that thing looked like so. And then it looked like so. Oops, got to approach that oblique asymptote. Ugly little sketch. Where's he less than 0 at? Here and here. Correct? So from negative infinity to negative 2, which counts due to the fact that that's got an equal to bar. Union from, where does this start at? Starts at 1, not included, since that's an asymptote of verticalness, all the way up to 3, which does count due to the fact that that had an equal to bar. These zeros count because of the equal to bar. Nice. That's enough.